examples 5 and 6, and we'll get 7 in this video as well, and that will finish off this section. So in example 5, a Hot Wheels car is moving at 3.4 meters per second along a track. If the car has a kinetic energy of 0.578 joules, what's the mass of the car? So this is my dream Hot Wheels car. Probably not the scale. Over here, fill in what we know for the formula. So you know the kinetic energy, and you know the velocity. So you simply have to do your math here and carry your algebra. So don't forget to square it. Multiply your answer by half. You get 5.78. Divide both sides by 5.78, and you end up with a mass of 0.1 kilograms, which would make sense for a Hot Wheels car. And calculate the kinetic energy of a 15,000 kilogram army tank charging forward at 100 kilometers an hour. Before you rush into that question, remember that velocity has to be in meters per second. So in this case here, to change kilometers per hour to meters per second, you have to divide by 3.6. So take your kilometer per hour, divide by 3.6, and you'll have it in meters per second. If we look over, put in your mass, your velocity now that is in meters per second, and simply work out this side. And you have a kinetic energy of 58 million joules. Sorry, 5 million joules. Last example, calculate the kinetic energy of a 25 gram bullet traveling at 3,600 kilometers per hour. So you may realize now that you need to do two conversions, change your grams to kilograms and your kilometers per hour to meters per second. So your mass would be 0.025 kilograms. Velocity would work out to 1,000 meters per second because you divide by 3.6. And there's nothing new in this. Just simply carry out your calculations. Don't forget your significant figures, and 1.3 times 10 to the 4 joules. How fast would a 13,000 kilogram truck have to be moving to have an amount of kinetic energy equal to the bullet? Well, we know the kinetic energy, we know the mass of the truck, and how fast would it have to go in order to have the same kinetic energy as the bullet? So you have to solve for velocity. So put in your kinetic energy. Notice that we're not using the rounded answer. We use our actual number here. The rounded answer is only when we present our final answer, but when you have to go back and reuse calculations, give the whole number here. And you may have noticed that in some of the other steps earlier in this lesson. Multiply by half, and then you're going to divide that into your kinetic energy. And don't forget to take square root. So the truck would have to move at 1.4 meters per second to get the same kinetic energy. And how many times faster must the truck go to quadruple its energy? Well, if we want the energy to quadruple, if the overall effect is to get it 4 times greater, remember it's a squaring factor involved here. So it'd have to go twice as big. So you would take the square root of that amount. Oops, sorry. I'll leave you with one last add-on to that. Okay, think about, here's what you should pull from this, and it's how I want you to think about it now. If you had a hockey puck, here's your puck, and let's say the hockey puck weighed 0.2 kilograms. And you could throw it to your friend, and you could to throw it at 20 meters per second. And I asked you to calculate how much kinetic energy was involved there, and what the impact would be if you took the velocity and doubled it. Now, because I said to double the velocity, does that mean that the kinetic energy is doubled? And I'll give you a minute just to work that out yourself. Okay, because I know you worked it out and just didn't wait for me to do it, you would have realized that your kinetic energy increased to 320. Well, doubling the velocity, what change does that make in the kinetic energy? Well, if you do a comparison, here's your new, divide by the original, the kinetic energy went up by 4 times the amount. So the big picture out of all of this that you should remember, that doubling velocity would result in a 4 times increase in kinetic energy because it's being squared. So it's a squaring factor. So if you tripled the velocity, what impact do you have on the kinetic energy? It will go up by 9 times the amount.